This video is the fourth video in a series on manual transmissions. Today we're going to discuss air shifting. So when we're shifting a transmission, whether it's high to low or if it has a splitter on it, so what we want to take a look at is the components that are used to allow us to use the air system on the truck to shift our transmission. Range and splitter. So depending on the transmission, how it's set up. So for instance, if we got a high-low range, our shift pattern would be first, second, third, fourth, fifth. Move the lever over into our high range and then go back to where the first position was, which is now 6th, 7th, 8th, 9th, and 10th. So this is only a range. So this gives us 10 forward speeds and 2 reverse speeds. Now every transmission may be a little bit different. For instance, if we take a look at this one doesn't have a range, it has a splitter though. So depending on, we have, again, first low, 2 could be first high, but we go 1, 2, then we put it back into low range, and then we got 3, 4. Then back into low range 5, 6, back into low range 7, 8, back into low range 9, 10. So this is still a 10 speed, but instead of having a range selector, we have a splitter. Now we don't need to split every single gear. We can go 1, 3, 5, 7, and 9, or 2, 4, 6, 8, 10. It all depends on how heavy the load is that we're trying to move. So if we're totally empty, we don't need to go to every gear. We can actually skip a gear. And again, one of the ones we talked about earlier was deep reduction. Now in the deep reduction, if we put the deep reduction in, we can't split the gears. So it's only when the deep reduction is out are we allowed to split the gears. And again, it may vary between models. So again, we need to know how the configuration is set up. Now when we're taking a look at the shift cover and the lever, again, our lever goes down through our tower and into the transmission to our shift rails, which will allow us to shift. Our shift knob will have our range and or our splitter switches on them. And again, every transmission may have a different knob, so you can't just use one that's a 13 speed or an 18 speed. You have to have a right knob to be able to get the right configuration in. So if we take a look at the filter regulator, then we have an air cylinder for the range and an air splitter or an air cylinder for the splitter. We have air lines that run up to a slave valve and then thin spaghetti lines that run up to the master control valve. If we take a look at the filter regulator, it uses sintered bronze filters, so it's pressed. So what happens is air pressure comes in from our system. Now our air system might have a pressure protection valve, which means the pressure protection valve doesn't open until 90 psi. So if the air pressure drops down, we may not be able to use our range and splitter. Some air systems aren't. So again, it depends on the manufacturer how the air system is set up on the vehicle. So it takes system air of, let's just say, 120 psi and brings it down to roughly 60 to 63 psi. And that's the pressure that's used throughout the air system for shifting. If we ever have to clean the filter, we can remove the cap, the 2 O-rings, remove the filter, and wash it out. Now if it gets plugged with oil, we're getting oil from somewhere and we need to find out why, because it'll just plug it up again. So one of the symptoms might be an operator comes to you and says, yeah, it's shifting really slow. Now again, some of the O-rings that we use aren't compatible with oil, so the O-rings could start to swell and that could cause some of the pistons to slow down. It could be that the regulator isn't delivering the amount of pressure we need. So something simple as putting a pressure gauge on and seeing what the outlet pressure is. So again, understanding how the system works will help you to troubleshoot it. So off of our filter regulator, again, it goes to the slave valve, and then from the slave valve it goes up to our master control valve. Now this master control valve has a lever for high range, low range. It also has a little lever on the side that is our splitter. Now again, depending on the transmission, we might be able to split low and high range, or we might only be able to split low range, or might only be able to split high range. It all depends on the configuration of the master control valve. So looking at a basic system, so off of our filter regulator we have air pressure running up to our slave valve. Pressure from a slave valve runs up to the range cylinder. Now it all depends on what's happening in the slave valve is going to determine if this range is going to move. So by taking a look at the slave valve, so again, air comes in, goes into our slave valve. It's also teed off and goes up to our master control valve. Now remember, the one that's the big one on the front is our high-low range. Now air there, when it's in low range, goes to the back side of the actuating piston, and we have an actuating pin. Now the actuating pin is the one that's in the transmission. Anytime the transmission is in any gear, this actuating pin is in this position, blocking the spool valve from moving. So air pressure also goes through the spool valve and goes down and moves this piston rearwards. That puts it in low range. Any air that was on the high side goes out and gets vented out to atmosphere. Now when we want to go from low range to high range, we can pre-select. We can move this up. As long as we don't go through neutral, this actuating pin is going to stay where it is. So we move it into high range, and it dumps the air out of here. Now this spool valve can't move because this actuating pin is preventing it. So what we need to do is we need to go into neutral. And as soon as we go into neutral, there's a spring behind this that will push this up. The spool valve will now be allowed to move. So here's our slave valve, here's our actuating pin, and again inside here our shift rails will move this over to prevent this from actuating pin from moving. So as soon as we get into the neutral position, actuating pin retracts, spool is allowed to move. There's no air pressure on this side, and now air can come in here and go to the high range side. Pressure on the low range side gets vented to atmosphere. So let's just say if we take a look, go back a few slides here, and we're in this position and everything's fine. But now we go into this position and we get air leaking out of the slave valve all the time. Where would be the problem? More than likely the O-ring in here. Same thing as if we're in this position here and we have air leaking inside our transmission out of our breather all the time, but we go to this position here and it's not leaking. It's the O-ring that's on the shaft for the high-low range that's leaking. It doesn't leak here because air pressure can't get by this O-ring, so we get no leaks, but in this position it can. So understanding how the system's set up is going to help you troubleshoot. Okay, now if we take a look at the splitter, older vehicles use this type of splitter, and it's usually located on the front of the shift lever. This type is incorporated into the handle itself. So if we take a look at a system that's got a high-low range with a splitter on it, So same thing is our filter regulator. One side goes out to our splitter. One goes to our slave valve. We have pressure that goes up to our master control valve, and then we have two spaghetti lines, one that goes down to our splitter and one that goes down for our high-low range. So right now we're in high range, low split. High range lever is up, low split. So what happens when we want to go to high split? So if we take a look at it, we have no air here. Okay, air pressure is coming up, pushing this spool valve up, blocking off the exhaust. Air pressure on both sides of the piston, because the surface area on this side is bigger, the piston stays in. Now what happens when we put air to the splitter? It pushes this little spool valve down, which dumps the air out of here, blocks the air off here from getting in. Now the air pressure here is higher than this side, brings it over and shifts it. When we take a look again, it's really simple how it's set up. One of the things when we take a look at the actuating pin, I talked about how easy it is to break this actuating pin off. So this is why I always remove the slave valve before you remove the top cover of the transmission, so that you're not going to break this actuating pin. Now when we take a look at how the lines are set up, so if the truck is new and no one's touched it, these are the colors of the lines, and a lot of times now they just use a black line for everything, so you'll have to follow where they go to on the splitter and or on the valve and up at the master control valve. So again, if we take a look at low range, low split, okay, so we have no pressure here and we have no pressure here. But when we go into high range, low range, high split, we're supplying air here, and again, in order for this cylinder to move, this is our range, high low, it has to go through neutral. But this one here, we got to be careful of pre-selecting it, because if I pre-select it and I take my foot off the throttle pad, the load's taken off the gears and this will try and shift, and we may not be ready for it. So if we're going to pre-select our splitter, we have to do it just before we're ready to split, because again, if we hit a bump and we've already pre-selected, it's going to try and shift on us. So when I take air away, this one's going to split, and air pressure, this is going to move up, this is going to shift this over. Now we talked earlier about taking a look at the shift patterns, and again, every vehicle will be different, so understand how they're set up. Now when we were talking earlier in the transmissions about an overdrive, so what they used to have was a setup like this, where low was first, then we went second, third, fourth, fifth, but an overdrive you went 3, 4, 5. And that's why you take a look at the underneath of the new shifter, and they have it set up so that you go 3, 4, 5. We'll talk more about that in shop when we're looking at the top covers. Now we have what's called automated transmissions. There are a manual transmission. It's not an automatic, it's an automated. The computer shifts. So our transmission ECU controls engine, so I can leave my foot down on the throttle and it will derate the engine, will depress the clutch, it will allow me to shift, and then it'll activate the clutch again. So all we have to do is, on the older models they used to have a clutch pedal, on the new models there's not even a clutch pedal. So what we have is a couple things on there. So we have a a transmission ECU that controls the engine ECU, and again they talk back and forth about what's going on. When we take a look at some of the components we have a shift controller. So when I put it into gear, let's just say I put it in drive, you'll see a D show up and it'll flash until that gear is engaged. If it doesn't stop flashing, it's not engaged. We have a range valve, a splitter valve, inertia brake, speed sensors, transmission control unit. We'll have a display which is down in here, and we have an XY shifter. So our range valve and splitter valve are the same as what we were talking about in the manual transmissions. We have an inertia brake. Now we have to be able to match the speeds in order to shift without it grinding. And what the inertia brake is it's a magnetic brake, and it slows the shafts down so that they're at the same speed. Now we also have speed sensors, so these speed sensors will be on the transmission, and they will know what the input shaft speed is, the output shaft speed, and the counter shaft speed. And with that, it can derate the engine enough, and so once the speeds all match, it'll allow it to shift, and then the inertia brake will turn off. Our transmission controller unit will control the XY shifter. Now, somewhere in space there is 6 positions. If we go here, the XY shifter needs to know where in space that lever is, whether it's in the neutral position, whether it's in low, so that when it wants to make a shift to first, the XY shifter moves it up, over, and up again. So the computer controls all of that. So we'll have 2 shift motors that are controlled by a Hall effect sensor, so it knows exactly where in space that shifter knob is. Now we can also put it in a hold position. For instance, if I'm climbing a hill and I don't want the truck to shift, I can press the H button and it will hold it in that gear. It will not allow it to upshift or downshift. And again, if this indicator lamp is flashing, it's in the process of going into a gear. So on our dash, again, some of them are on the shifter, we will have a display that will tell us what gear we're in. So this is what our XY shifter looks like. So we have 2 shift motors, and again our Hall effect sensors know exactly where they are in space. And we have electronic shift solenoids. And again, these are all controlled by the ECM. So the inertia brake provides for the braking and subsequent slowing and rotation of the counter shafts. The inertia brake has a clutch pack comprised of clutches, friction plates, and clamped together by means of a ball ramp actuator and a cone clutch. The coil is electromagnetically pulled an armature into friction contact with a grounded taper surface, thereby forming what is known as a cone clutch. So if we take a look internally inside it, here's our clutch packs. Here's our coil. When these coils are energized, it allows these clutch packs to slow the countershaft down. Some of the shift levers are going to have an upshift button and downshift button and a gear selector button. Some of them have push buttons on the dash. Fault codes, don't memorize these. Again, if you have a fault code, you're going to look it up and find out what's causing it. Some of the new things that they have because of computers is, let's just say for instance, I've got my lockers in. Over a certain speed, the engine and transmission ECMs determine that we're going too fast for lockers, and it will disengage them. our PTO on our transmission. We can't start a vehicle if the PTO is engaged. So customer calls and says, yeah, I can't start my truck. Make sure the PTO is disengaged if they have one. It could be the clutch pedal switch has failed. So understanding the system, again, being able to troubleshoot and understand what we're looking for. If we're doing step-by-step procedure checks, for instance, here we're checking pin locations. Checking the resistance, don't miss a step. If you think, oh yeah, well it's probably going to be good, always check all of them to make sure that we verify that there is the proper sequence of events have done and we've checked everything, so we're not going back double checking something that we've already checked, or just don't forget anything. And that finishes off shifting of transmissions and automated transmissions.